So, law of cosines continuing. You may notice the formulas are the same. Yes. Now, could I, if I wanted to, when looking for an angle, could I go in and change it up into this format and then use my second cosine? I could. But I also have the choice of continuing to use those same three equations and just solving for the variable term. It's your option. So here's what we're going to do. Find the missing angles and missing sides for each triangle. Well, for right now, it's going to be missing angles, because that's all we have. But here's the kicker with this. Different from law of sines, when we had that rule on Friday that you find your corresponding side and angle, then we use the smallest number in the law of sines for our second step. Now if it's all three and we're working with sides only, we're going to be dealing with the largest, because due to rounding, we'd have issues again if we were all using ones that were different depending on how we wanted to do it. So here's my personal preference. I either could use this fraction and then use second cosine, or I also can plug it in here. Either one will get me to the right answer. So it's a personal preference thing. If you want one equation only to worry about, we play with this. If you do it this way, we do it this way. I'll do one of each. I'll use the fraction one first, and then I'll use this one when we do number 2. So I will be looking for the cosine of A. I'm going to give myself the little -1 there to remind myself. Hi. Sure. So we're going to have b squared plus c squared minus a squared over 2 times b times c. Now, let me make one thing of note. If you were looking for angle B or angle C, this would change. And what would change? Well, the A would change with whatever variable I was looking for. So if I was looking for the cosine of B, that would be an A, that would be an A. Okay. So I'd have to change that around correspondingly. But let's get this plugged in, make sure we're not having any issues. Make sure I'm in the right mode. Okay. Now, just me again. I would either type those in separately or make sure I get parentheses working here. So there's my numerator. And here comes my denominator. And again, I'll get the funky little decimal, which tells me, oh yeah, that's not the actual angle that I'm looking for. And I'll work that out, and I find out that A is 82.1. Now again, I like using that fraction, to be perfectly honest. It's going to be quicker than some of the other ways. But the nice thing now is, now I have my side and my corresponding angle, so I can use the law of sines now. So the next question that normally comes up, we're going to explore this. Use the law of sines to find the other parts. Do I have to keep using the smallest side? Could I use B instead of C and get away with it? Well, let's use the smallest one first, and then we're going to check into this and see, do we have to do it this way, or could we get away with it? All right, so we're trying to figure out angle C. So when I'm punching this in, I'm always going to cross multiply whichever diagonal does not have my variable term in it. So 14 times the sine of 82.1. But then I'm going to divide by whatever is cross multiplying with my sine of C, which is 22. And again, I'm looking for an angle. Again, it's sine that we're doing now. And that matters. So with our degrees, again, typically we go to the nearest tenth unless we're told to do otherwise. The more accurate, the better. I get my C, and then my third angle, of course, is just 180 minus the sum of those other two. But I do, especially on this first one, since we're just getting started, I want to see, could I get away with it if I would have done it the other way around? Let's find out. So if I would have decided instead to do B instead first, let's see if my answer would have changed at all. Because we want to keep things as flexible for ourselves as we can, but we also want to get the answer right. So let's see if we'd have had any rounding issues if we'd have done it the other way. Doesn't look like it. Okay. So, in other words, if you want to just keep doing it and you want to keep doing it the easy way, you want to keep remembering, okay, I'm just going to keep doing the smallest one every time. That's okay. But if you're doing it with 3 sides, you have the option, okay, you have some flexibility that you can work with. So don't fret too much otherwise about that, okay? Now some of you may be like, well, what if I would get confused if I wanted to find a different one besides A, even though it was be A here again, and I wanted to use this little one because that leaves me less things to think about. Can I do it? Sure. Okay. If I want to do it that way, I still would use my biggest, and I'd say, okay, I'm going to use this first formula. I have an option. So I'd have 39 squared equals 14 squared plus 27 squared minus 2 times 14 times 27, and I'm looking for the cosine of whatever angle A is going to be. Okay. Here's the only thing with all of this that I don't necessarily like, why I might like the fraction a little bit better. Because it doesn't give me the flexibility to type this whole thing in at once, and I'll show you why. So I'll get my 39 squared. Okay, so I got this side. When I get to this side, this is all connected with my cosine of A. I can't type all of this in together and just slap that in front of cosine A. It doesn't work that way, because this is like having a variable term on it. So what I have to do if I'm going to go this route is I kind of have to break that right side up a little bit. So I'd have 14 squared and 27 squared. And then I'd combine my coefficient of sorts for my cosine of A, and I'd do that. Because now I'm solving it like an equation. I'm almost treating this like I'd treat minus 756x. So I'd subtract the 925 over, because again, it's like 925 minus 756x. I couldn't combine those terms anyway. So I'd subtract that over. And then I'd divide by negative 756. Both ways, that or the fractionals, both get me to the right answer. It's absolutely true. It's just a preference thing. You only want the one set of formulas to work with, or if you're comfortable with the fraction, that's fine. So A would be 142 degrees. And it'd be the same if I'd have plugged it into that. Once I get there, I can go about finding my other angles. And again, it's a comfort thing. If you like doing the same thing, we'll keep going with the smaller when we do this. But I now have my corresponding side and angle, so I can use the law of sines from here on out. And then I just play the cross multiplying game. The one that doesn't have the b, we'll do that first. And we'll divide by whatever's with my sine of b. So b looks like it's about 12.8 degrees. And then again, we'll just take the sum of those two, subtract it from 180, and we've got C. And there aren't a whole lot of surprises going on with these, but I actually do want to work one of these through where that fraction would change a little bit in case some of you do decide you want to go that route. So let's jump down to number 4 because we'd actually get to move that around a little bit here. So if we move down to 4, and I know it says find angle A, we'll get there though. I'm going to go ahead, I am going to start with B. So if I was looking for angle B, I'd have the cosine of B. And when you look up at the fraction that's up top, that b squared would get replaced with a squared. Now, a and b are going to change places. So a squared plus c squared minus b squared over 2ac. So you'll notice the only place I see b is this minus part at the end, just like I did up top with the a. So now I'm going to plug those in that way. So I'm like, all right, let's get this on here. So I've got a squared plus c squared minus b squared divided by 2 times a times c. And then we'll find that angle measure. Now some of you may say, if I'm not looking for all the angles, could I get away with going ahead and finding A first? Well, we might have to see in a minute here. Because now that I have B, since we're going along with this, I've got my corresponding side and angle. And we already saw before that we can live dangerously and not use the smallest one. And again, we'll cross multiply with what doesn't have the A, divide by the number that's being multiplied by our A term, and find our A value. So again, just comes back to what you're more comfortable with. Keeping the same formula or just dealing with that fraction formula and being able to make the adjustments on your variable terms. At least there's no surprises like there are with the multiple triangles with the ones we're working on today. So if I flip over, again, we're going to stay into the same thing with 5 and 6. I'm not going to worry about that quite so much as I am the story problems, of course, down at the bottom. So I want to go to those first, and then if we want to take a look at another one of these, we can. So we've got these 2 radar stations that are 2.4 miles apart, tracking an airplane. Straight line distance between A and the plane is 7.4 miles. Straight line distance between B and the plane is 6.9. What is the angle of elevation from station A to the plane? In other words, what's going on right here? So, I want to find angle A, and I think this is a great time for us to do a little bit of experimenting. Let's find out if we're good boys and girls and do this the way that we're supposed to, and then do it the other way. Can we get away with it? So I notice which side is biggest. Side B is. Well, I don't want to find angle B first, but it keeps telling me I'm supposed to use the biggest number when I'm doing this. So, okay, I'll play along. So I start to think, which way do I want to do? I like the fraction better. So I want to find the cosine of b. So I've got a squared plus c squared, because again, if I were labeling all of my different pieces, it would look something like this, which may not be a bad idea to do since you're kind of plugging values in based on that. Minus b squared over 2 times a times c. And again, just using that other formula that we did, the one-liner, and then just solving for it that way, we saw that works too. We just want to get all the options out there. So 6.9 squared plus 2.4, oops, squared minus 7.4 squared. Get that closed in. And then 2 times 6.9 times 2.4. And let's get the inverse of my cosine. So I get that set. Oh, good. Thank you. I find out B is 92.4 degrees. Okay. We already found out before that we can be a little sneaky and that we do not need to use this next and have to put ourselves through a bunch of other stuff that we don't need to do. So we know at this point, here's my angle and its corresponding side. So I can do that. And if I want to find A, I'm going to go ahead and find A now. So once I get that set up again, do my cross multiplying. Oops, I forgot to do my dividing before I did that. That's okay. But here's the question at hand. This is what I was looking for, so I found my angle of elevation. Could I have done that right off the bat? Could I have used this first formula to do that without ever having to do it? I like trying to be a rebel at times. I think we need to try this. So let's see if we could have skipped this middle step, or if it's legitimate what we're being asked to do here. All right, so if I'm looking for the cosine of A, I'd have 7.4 squared. We'll kind of flip back to the front here. I'll do it on mine so we don't get ourselves too messed up here. Plus 2.4 squared minus 6.9 squared over 2 times B times C. All right. Get down to it now. See if this is a myth. Are we going to be a myth buster, or are we actually being told the truth here? Let's find out. Two times 7. Moment of truth. Oh. You're like, well, what a bunch of hokey that is. Why are you telling us we've got things that are going close enough with these that you're not seeing the big gaps that you would in others? The main reason behind that, putting the biggest number in to kind of work with it, was just getting everybody to get the same answer, because sometimes with rounding, if you go to whole numbers, it can make a difference, but with us going to tenths, it's really not going to. So if you want to go straight for the one that you're looking for, go straight for the one you're looking for, because it's silly to take all the extra work up otherwise. They're like, okay, we have learned something new and we are happy about this. So we have busted that myth that we necessarily have to go the other route. If you are a rule keeper, though, and you see it says that and you want to do it, you keep right on doing it. All right, last one. Ooh, no picture. Shady Pines Campground. Campsites A and B are located 80 meters apart. The camp office is 95 meters from Camp A and 115 meters from Campsite B. When the ranger is standing at the office, what is the angle of separation between campsites A and B? In other words, find angle C, or whatever you wanted to label that. And we just found out we don't have to go through all this other junk that's going on. If I want C, I'm going to go find C. So, the cosine of C, and they're like, okay, we haven't done C yet. We got to piece this one together. So we're going to have B squared. I'm going to label my sides so I don't mess this up. So B squared plus C squared minus A squared. Did I just... I followed the formula exactly, and everybody was going to follow me. Why would I go and follow it exactly? I'm not finding A. I would have been if I was following directions, but again, we are being rebels and not following the directions. This does not mean you do not need to follow directions for anything. We don't want to be that rebellious. I am going to write it over here so I don't do that again. Okay, that's what I'm doing. So, B squared plus A squared minus C squared over 2AB. Now we're in business. Keep myself out of trouble now. And it looks like C is going to be about 43.5 degrees. And just to let you know, I did do it the old-fashioned way when I put my note sheet together, and I got the same thing. So, be rebels, go for what you want right away. The assignment down at the bottom is what we'll be looking at here for assignment 3 in our homework check. And like I said, tomorrow we will be looking at story problems like crazy. Uh-oh.
So the denominator will always be bigger than the numerator, right?
Hang on, let me bring this back up.